I believe to be kind of the standard interface for using it. Immediately you will see that we have the console, and in here you can type in commands, very basically things, as simple as, 2 plus 7, and you will get an output of 9, which is what 7 plus 2 is, of course. There's many other things you can do in the console, and you will see how to do that later. In using R, generally you will work out of a script, though. And a script is basically a line or a string of commands, essentially code, that you can use for various purposes. So to get started, when you're making comments in the code, which can be useful at times, you use the pound sign, I guess more commonly known as hashtag these days. So you can see that this is a very commented script. If you would like to assign a value to some variable, then you just use the I guess I don't actually know the character name, but I guess left bracket and then dash to make an arrow. If you would like to run something, you can either put run and it will run the current line, or if you want to run multiple lines, you can highlight them and run them. You'll see that the first time just assigned 4 to A, and then the second time it also assigned 7 to 2A. Additionally, with this, if you can, the equal sign works as the assignment operator as well as the arrow, and you will learn later that actually the double equal signs is the logical equals that we think of it. Immediately to the right, you'll see environment, and these are basically every kind of variable, file, etc. that now exists in the, I guess, working environment. You can also have a history tab, which is basically everything that's run. This was not from this, and environment is important to make sure that we correctly assign to something. So again, if you can just press in PCs Control Enter and then Command Enter on Macs, which I'm using. That will also run a line of code. So you can see here we're assigning high 1, 2, 3, 4 to A3. With one thing you'll notice I've done, you cannot you can end a variable name. They can be multiple characters, but you have to start with a letter, and you can have as many other letters or numbers after that. You cannot start with you cannot start with a number, just a letter. You can see if you type in the console, let's say like 3A, let's assign that like 6, right? So you get an error as expected because you cannot create a variable that's 3A. So in assigning high 1, 2, 3, 4, as that is a string and not a numeric value, quotation marks have to be used, as you can see are done. And if you want to know the type of variable, you can just run it, type of, and it shows character as expected. If you and then this is another use of the console. If you want to just do something that not add to the code, let's say like type of an A2, you get that it's double, and that's just I guess computer science terms for a certain way that that numbers are stored. But if double pops up, then it is numeric. Something that's kind of fundamental to R is that you use vectors, and that of course has many uses in statistical analysis, etc. So we're going to assign the numbers 1 through 5 to A4. If you use a colon between two numbers, it'll just give the integer sequence between those two numbers and assign it as like. So we're assigning A4, 1 through 5, you see that there's, I guess, two ways that in the environment shows it is. It's int 1 through 5, which is just 1, 2, 3, 4, 5. Likewise, if you want to add several maybe out of sequence numbers to a vector, you use the concatenate function, which is C this. And another thing to bring up is that there's a help tab. To access that, you can just type in help like that, and it'll bring you there. But if you click on the tab, you can look up different functions. So here you see the C, which is combined values into a vector list. That is very important. And then again, a pretty important part of using R is that you're not going to remember every function. So if you kind of learn how to, like, the general principles of computing and how to use R, then that's really that's the goal, because you can always reference what specific commands mean when you need to use them. Actually use the concatenate function, command enter, and now you see B will pop up. Numbers, I guess I don't know why it does not say integer. I think that's just because concatenate can be used for whatever. So right, you'll see 98765 as expected. It's very, whether you're dealing with vectors or really some column of a data set or what have you, many times you'll want to know what the length is, or rather, how many entries you have. So the length function will give you that, and you see the length is 5 as expected, and as you can see here. Likewise, let's go with something bigger. Let's do B2 to 1 through 10. And now we're going to add B and B2. You might find that strange, and initially I did as well, that that B and B2 actually add, and that's because the size of B itself is a factor of B2, in that in that one has a length of 5, the other has a length of 10. So consequentially, B will just add twice to B2, which if you did the math out, that is what would occur. But if they are not multiples of each other, then they won't add. Of course, if they're the same size, they will add logically. If we would like to call, a part of a vector, or a part of a vector, you type in the name of the variable and then in parentheses the location. So the seventh I guess entry of B2. Doing that, we see that that's 7. I mean, and as you're doing a list from 1 to 10, that makes sense. If you do negative something, it'll do everything but that. So B of -7 gives you B2 with everything but 7, which you'll see as there's a gap from 6 to 8, and that's of length 9. Likewise, if you want to do, this is where the colon comes in handy again, because we want to do 3 through 6. So like we used with assigning A4, you just, you do B2, 3 through 6, and then you get 3 through 6, not because you referenced 3 through 6, not because, right, but that's because it's an integer sequence, so logically it's going to return 3 through 6. If we want to just do that for B, and then did like 3 through 5, right, we'll get 7, 6, 5, which corresponds to the last 3 entries as expected. To create a matrix, which it can be used in many different applications. To do it, we are going to assign it, and you use the function matrix, the first, so now we're getting into slightly more complex commands than something like concatenate, which you just add what you want to put together. So the first entry of the matrix command is will be what you are putting into the matrix. So in this case, I could have just done 1:4, but I decided for whatever arbitrary reason to do the concatenate function. So that's the first entry. Then you will say how many rows you want and how many columns you want, and whether or not to add by row or by column. In that, as R goes along this list, as you max out the number of columns or rows, or you when you move the next one, how does it fill by row or column? So the default is by row equals false. That is, it fills by column. So we'll just do this command. If we now view X, you see it filled 1, 2, 3, 4 by column as expected. Now for matrix Y, you don't actually have to type in everything, in that you don't have to type in the by row equals false. Actually, it will by default do that. So, and you don't actually have to, if you have the number of rows and number of columns in the right order, then you don't even have to do n row and n col equals. You just have to type in the number. So this will create the same exact matrix. Right, fill by column, 1, 2, 3, 4. Moving on to something larger, you can use the sequence function, and it is seek, and then the from equals is the starting value, the to value is where it ends, and then what the difference is between consecutive terms. Again, you don't have to use the from, the to, and the by equals, but so that for demonstrative purposes, we will do that. Here, I am only specifying the number of rows to be 2, and I am filling it by I'm actually filling it by row because I decided that would be fun to do. Of course, if you are specifying the number of rows, then you have to fill by column. Now doing number of rows equals 2. I'm leaving columns blank, and R will just figure it out based on the number of data entries with the 2-row limit. And I'm saying by row equals true, so it will fill by row. You can either do TF or true in caps or false in caps. R will understand them all. So I do that, and you see it ran. And now this is admittedly a much larger matrix than before. So I'm going to actually assign a certain part of the matrix to new variable z1. So unlike calling something in a one-dimensional thing, you have to in brackets you have to call the row number and then the column number of what you want. So in this case, we're calling row 2 and then columns 5, 8, and 101. Again, we're using concatenate because we want to call multiple columns in this case. So to z1 we will assign row 2 and then column 5, 8, and 101 from the matrix Z we created. Now let's look at the dimensions of z1, and that is null. I'm not really sure why actually. That is null because it's not actually a matrix. So if we do dim z, we get that it's 2 by 201, which is expected. Now let's actually I'm going to show you the view function, and that will actually create a tab that lets you see what certain variables or whatnot, or how they look. So we'll do view z, and z will pop up. Of course, pretty big matrix that filled by rows. You can see difference of 5 between each consecutive term. This is not very a very useful matrix right now, just for learning purposes. So let's view z1 because we wanted to see if it worked, and if we were right. So we see that is just a vector, not a matrix, because we didn't specify it that way, and it just called, again, row 2, columns 5, 8, and 101. Moving on, you can do various statistical analyses, or not really statistical analyses, but just look up very simple summarizing statistical measures. So let's look up the mean of 4, 5, 6, and 7. So it only takes one argument. So if I just did mean of 1, 2, 3, that wouldn't work because it actually only takes one argument. So we have to concatenate or put in a vector. So we're going to do mean of concatenate 4, 5, 6, 7, and as expected, you get 5.5. We can try max, and as I said, you can just reference something, or a vector. Again, we defined b2 earlier, so we can take the max of b2, and it's 10, which we know to be the case. Right. So now we're going to create a slightly strange vector, and you see here I'm just concatenating a bunch of random things, all of which you've learned about except for not available. So sometimes in a data set you will have a blank entry, which is basically just an A. So it's nice to just be aware of that occurring. So if we assign z2 as such and then view it, you'll see that there's some not availables where I've assigned it, and you see some at the end, some at the beginning. So there's a very simple way we can replace not available. So there's a is.na function, which it basically just it will look to see if na exists in a certain location. So z2, right? And then we're using the brackets to call it, and then is na z2, which basically means you're where there is na and z2, and then we're just assigning zeros to that. So we do that command. It is a little bit confusing in that you have to use z2 twice in this, but that's basically this part is the one that will actually find where in z2 there are NAs, and then the more outer command is actually the act of reassigning not really reassigning, but assigning zeros to NAs. So now we're going to view z2, and where you saw some NAs, you see zeros at the end, and so that's and sometimes in the working large data sets that is quite a handy command, because you don't want to simply it's not fun to look up where every NA is. If you just have a command that will find it, then that makes your working more efficient. Also, you can make functions in R, which have many uses. So to make a function, it's literally kind of a variable. You don't have to specify the type. So you have f. We're just going to do f, basic function, pretty generic, and use the function command. And then right after functions, you have in parentheses your arguments, or your inputs rather. So I'm just going to do basic x and y. Just do a nice 3D function, and then in curly brackets, I don't actually know the name of them. You do what the function is, or what you do the inputs. So we're just doing z equals x squared plus y squared, and then semicolon, return z, because you want to return z. Note again that in this case it is kind of an assignment operator kind of thing. So you could actually write it like that, and that will work fine. So we're gonna use the function, and then we're doing x comma y, so f of 1, 2, and we get that is 5, which is expected. Now, many times, and probably pretty much all of the use you will use R for is, working with like some data set or something. So the get WD function will just tell you where your directory is. So right now mine is users/Ian Ramsay, and that is not where I want it to be, because currently I have a folder called R scripts on my desktop where everything is. So the set WD function will set a working directory, and basically what this does is, instead of typing, if I set a working directory, if I want to load a file, I don't have to give a detailed location. I just give the file name, and it will search the working directory for that, which makes things a lot easier. So you do in parentheses, quotation marks rather, you just do the location. So I'm going to set it to R scripts, and then now I'm going to actually read a CSV, separated values file. So what you do is I'm going to assign the variable name bike data, capital B, capital D. R is case sensitive, so I'm going to assign and then use the read.csv file. Read.csv function. So we're assigning it's read.csv, and then in quotation mark again the file name. So we're reading the CSV file bike.data.csv. So you use that function. Now you see in the environment that bike data has loaded up. If you want to look at some summary statistics, you just press the down arrow, and you see that there are 9 variables with 121 observations. So basically 9 columns, 121 rows of data. Not entirely that large, so we're going to actually view it. So view bike data, and you see you have user ID, age, gender, etc., and 121 rows as expected. Sometimes you will want to just see, the names of the various variables. We already saw that, but if you had a really huge data set and you just wanted to copy and paste all the names, just do names bike data, and you get user ID, age, etc., as we had seen before. If you also want to kind of see what like the first few entries are observations, as R calls it, what they are, you can just do the head function, and that gives you basically just the first 6 actually observations for each variable, and that can just be useful to see like, oh, like what am I looking at. So when you're referring to a variable in a CSV file, and I think that's universal for whatever file you're looking at, you do, how have you assigned it, bike data, and then $age, because we see age is one of the variable names. So we're just going to assign age with bike data $age, and then we'll see that pops up as just the vector, and I want to see what the mean age is, and so we get it's about 36.5 years old. Likewise, for something that's not numeric, levels will give you basically the different non-numeric values or string values that are in a certain column. So I'm going to do psych frequency, bike data, $psych frequency levels, and we get daily, less than once a month, several times per month, and several times per week. Likewise, I wanted to maybe know the length of this. We already know it's 121, but it just confirms that. Now we're going to do a for loop. And a for loop is basically if there's some process that you would like to carry out that's very repetitive. Let's say, a conditional thing, like if something in a certain data file says something, do that. It's basically like you're going, it has many uses, but in terms of data cleaning, it can be very useful if you just have to go through and look if certain conditions exist. So it's literally for, and then you're kind of giving it a range, and then in curly brackets, what to do. So we're doing x. We're gonna use put x through a certain range of numbers, x, and then you type an in, and then I'm starting at 1 through the length of bike data cycle frequency, because the length of bike data cycle frequency is the length of the data set. Of course, if we wanted, we could hard code this as 121, but in general, in case you need to use a script for something else, it's just good to not hard code something. And then we're going to use the command if else. In this, the first entry is the condition. The second is do if true, and then do if false. So if bike data x comma 6, because we're going through x, so that would be row x column 6. Looking here, row 6 is 1, 2, 3, 4, 5, 6 is cycle frequency. So if that is daily, see again we have to use the double equal sign to not, because it's not a matter of assignment, it's a matter of I guess equality, or it being equal. Then sorry, actually we are creating, before I did this, I need to create an empty vector x, because we're actually going to transfer the cycle frequency to another vector. So x, location x is, and we don't have to use row column because it's it's 1 by n matrix. If that is so if daily is true, then we assign a 1 to that entry in x, and then if false, we assign 0. So I'm going to run this loop, and now let us view x. So we can, because we're not actually, this is not an actual like process I'm creating, is we're just learning, we can just use the console to view x, and we see that 1s and 0s appeared depending upon if it was daily or not. And that can be sometimes useful if you're doing a regression, or you just need to replace a certain value. Now this is a little bit faster, but what I'm going to do is replace the cycle frequency column with just 1s and 0s, and one way you can do that is cbind, which basically just bind or puts together a bunch of different I guess variables, matrices, vectors. They have to have the correct dimensions, which this does, as x has length 121, as does everything in bike data. So I'm assigning new bike data with using the cbind function, and these are all the arguments that you are going to assign. So I'm doing bike data. If I did blank, that just means all rows. And then columns 1 through 5, we see that 1 through 5 are all the way up to employed. And then we're doing x, the one which is the 1 zeros for daily or not. And then bike data 7 through 9, which is just the last 3. So assign new bike data, and then we're gonna mark that column, of course, as daily user now. So again, this is kind of a double call thing, like it was when we did the replacing with x's and zeros way up here. So we're basically assigning daily user to call name in new bike data, and then this is in brackets. This is basically searching, because right now the name of the daily user is X, because that's where we put the ones and zeros. We have to do call names, new bike data equals, and double equals here again, equals X. So we're just gonna run this command, and now let's view new bike data, and you'll see that it's really identical to bike data, except for now we have daily user, and then the ones and zeros there. So again, recapping the call names, basically the outside, the call names, new bike data, you're basically, reassigning the one column name, and then the bracketed thing refers to only where a column name is, column name. Now it kind of sounds like CALL, but I meant column. Column names equals X, so we're only searching for there. Like if I omitted this part, it would just rename everything daily user, which is of course not useful. Now that we have done this replacement, let's view new bike data, and you'll see that we have now this file has daily user instead of X, which is as desired. So moving on, sometimes maybe for viewing kind of purposes, or for kind of just visualizing trends, not necessarily like some statistical analysis, you might just want to make something a category. So this has many uses in various analytical techniques, which you'll probably learn in the course. But sometimes instead of having like a numerical variable, you might want to have a factor, or just something that's kind of something that is in a category. So in this loop, we're basically, if we see in new bike data, you see that there's distance traveled. So what we want to do is, based on the distance they travel, we want to categorize it into a certain category that characterizes their usage. So we have here that we're basically going to make a for loop, and again we're doing same process for x in 1 to length of bike data cycle frequency. So that just cycle frequency again. You're not hard coding, but you're making it applicable to this data set. Really, what the length of the length of bike data, right? Which we know is 121, but then again, we're just not hard coding. So beforehand, we did an if-else command, and that's literally if-else. Now we're just going to do an if command, which uses else also, but it just using this specific format is more helpful when you're doing a multi-conditional statement. This is not a multi-conditional statement, but if you had, if we were categorizing something to, more than 2 things, you can use if-else, but using if and then else is a little bit easier to type in, just because in if-else, you would have to kind of do a multi-layered if-else within the if-else command, versus here you can just type out else. So what we're going to do is, if new bike data, which is the new file we've created, $distance, which refers to the distance column that we discussed before, and then x is the column position. So if that's greater than 7, then new bike data distance x will be labeled heavy biker. So in using this command, instead of doing the kind of the if true thing like in if else, you basically say if, and then you give the conditions in parentheses, and then in nothing, just kind of after the parentheses, you just write what you would like R to do, and then you write else, and then basically you'll give the false, you'll give what will happen if false. So new bike data distance at $distance brackets x equals light biker. Again, remember that this is the assignment operator, and we are using because we're not storing it, we're storing it as a string or basic or character in our language. Right, we have to put in parentheses. If we were doing a value like in the if else before, that's a value, so you don't use parentheses. So let's run this for loop, and then we're gonna view new bike data again, and you'll see here, these distances are light bikers, these are heavy, and then basically the heavies, of course, correspond to greater than 7 miles usage. Light is less than or equal. So if, sometimes you might want to, make categories, and this in a data set functions to do that. Of course, you could just replace it with ones and zeros, but I wanted to show that you can use replace with numerical variables, which was characteristics of distance before. You can replace it with character. So now, because we have a new file, we're going to actually create that as something that's out of the our console, and by that, basically, we're saving a file that we can give to someone else, use for later work. So that to do that, you use the write.csv command. The first entry is the variable, or I guess data set that you have saved in R that you're using. So we created new bike data. So write.csv new bike data, comma, file equals bike data 2. So the second entry of the write.csv command is what the name of the file will be, and this will save in your working directory. So if you remember from before, that is in my R scripts folder on my desktop. Again, you don't have to do file equals, but it's more, it's just makes your coding clear so you know what you're doing. So write.csv, and then if we actually, if we go to that folder, you'll see that bike data 2 now exists, and so that was actually, interesting enough, that is an error, because I should have actually written it as bikedata2.csv. So again, right, I guess everyone makes mistakes. So let's write that again. Now let's pull this down, go to that. Now we have bikedata2.csv, and then now instead of opening in text edit, well, it's now trying to open Office, which is not what we want. Right, so let's just click out of this. So again, sorry, it is now a CSV file instead of a text edit file. You can see here that the preview of it shows it as a nice CSV spreadsheet, which is expected. Okay, so going back, we've written the file. That's all nice. Again, just a reminder to set working directory. We're going to read a larger file now. So this is train.csv. It doesn't have to do with the thing train. It refers to training. So if you're basically, we're trying to create a regression based on training data that will be used to predict things that we don't have the dependent variable for. So let's just read train, and then let's view it. As you see, this is like 10,886 observations across 12 variables, and this supposedly, I guess, slightly ironically, is actually bike sharing day. So this was just the new bike day was just a kind of arbitrary thing about user characteristics. This is actually from a bike sharing program in DC. You see here like at a certain date, you have whether or not it's a season or what the season is, the holiday, if it's a working day, the temperature out, I think afternoon temperature out, humidity, wind speed, and this is how many casual users borrowed a bike at this time and how many registered users for a total count of the bikes that were used. So again, I just showed it to you, but head is useful because you kind of just see all the different variables and what the variables look like for the first 6 rows. So we are going to do a linear regression on this. To do that, you use the linear model LM command. It's important that you actually save a linear model to some variable. So literally just do linear model and you use the assignment operator to whatever you want to call it. So I'm using test_reg for regression. So in the linear model function, you do the dependent variable tilde whatever dependent variable you want to do the regression on. Dependent variable and then whatever independent variable you want to do it on. If you want to do a multi variable regression, you just do plus. So you see here that I'm not doing. Okay. Oops. You see here that I'm not doing train $count, which would refer to this. That's because I'm specifying data equals train. This you can do. You could do train $count and train $temp. But the reason that we are doing this is because when we're using the regression to make predictions, you have to kind of have the same variable names across it. So instead of doing train $count, you actually just do, after you do the kind of regression argument, the next entry is you're just doing data equals and then where you're getting the data from. So count, we're doing a regression to see how temp affects the count, and then the data set we're using is train that we had just loaded. So let's do that, and then use the summary function of however you save the regression to see how it came out. And you see, right, what is being called, and it's linear model that as expected. That's the formula. That's the data. You see some statistics, and then I guess most importantly are the coefficients. You have the intercept, and then the I guess in this case, since we're doing 2 variables, I can just call this a slope to see how temp affects the count. You have standard error, t-values, and then the p-value. Of course, this is a very low p-value, so there's definitely an effect that temperature has on count. Of course, multiple loss squared is pretty low, so it's not like a very accurate prediction. But that's kind of how it is. Sometimes you might want to plot something, so we're not. Again, I'm just doing train $temp, train $count. Because it might be nice, and like obviously see here, it's not like that useful of a tool because there's so many data points. If you were wanting to make it useful, you might want to group them, but we will not. But again, plot, you just do you do y variable, comma x variable. Plots can get more complex. You can call them differently, but again, that's why computing is so nice, because you can just look up the plot function, right, and then you'll just basically get all the inputs. Again, sometimes the help function is not always as useful, so if you literally just Google plot function in R, you'll get to some form which is actually a little bit more useful. So sometimes when you're running a regression, you might just want, so that you don't, for various reasons, but for I think the main being so you don't overfit, you might want to take a random sample of your data set, and with that random sample, you will run a regression on that random sample. So this is not, there might actually be a function R that does this, but I couldn't find one, so bear with me as I explain the code to do this. And of course, later on, if you want to do sample, you can literally just copy this this code, because I will provide the R file, and then just modify it to your data set. So I'm just defining n as the sample size, pretty standard. Here I'm using 100. And then again, when you're doing a regression, you want it to come out of a data frame. So I'm creating a matrix with a number of, since we're doing I'm going to do a regression between atemp and count. Right, so I'm making a matrix with number of columns equals 2 and the number of rows equals n. So it's a 2 by 100 matrix, and of course each row will be a set of data points. So I'm making a data frame as such, and then I'm naming this matrix, each column, as atemp and count. So to do this, you do names, in parentheses what you're naming, and then in brackets I guess the location. So basically the first column will be named atemp, second will be count. It's not quite the column name function, but this works, and we know, because we want atemp to go to column 1, count to go to column 2. So let's just run this code. Right, we see that sample.m, the matrix, 100 rows, 2 variables, or 2 columns, shows up, and now we're just going to name them for just to see that occurred. We're going to do sample.m and view it, and you see that while currently there's NAs, but there's nothing in, it's a, I guess, null matrix, we have atemp and count as desired. So we're going to, because we're kind of randomly selecting, we're going to do a random process, and you do set.c to just keep, I don't entirely understand it, but basically this is good when you're doing random processes, but basically it keeps the algorithm the same, and then you just set c to any random integer you want. So I'm just doing 1. You could do 100, but it's just good to, you just want the process to stay the same. Now random will be, I'm just creating a random, it's not a random variable, but I'm calling it random, and it's going to be a list of integers randomly selected. So so we're using the sample function to accomplish this. So the sample function, basically you give a range of values from which you want to pick, and then so this is the range of values, and then this is the how many you want, and then do you want replacement or not? No, because we don't want, we just don't want replacement. Once a variable is picked, that's the only time it's going to be picked. And then the prob equals null. We want that to be null, because that's basically, do certain things get different weightings? We want the selection of each number to be of equal weight. So prob equals null, replace equals false. Again, this is the range of values you're picking from, and this is a length. So what I did is, the range of values is, remember this again is the kind of integer sequence, right? So 1 to length of train $count. So that's basically, length of that is how many entries there are, and we know that length of train $count, $count rather, should be 10,886. So if we actually just type that in right, we do get that number. So the list we're sampling from is the integers from 1 to 10,886. And then the length of the sample size is the length of, actually, in this case, it's fine that this will be the n value, as you see here, right? So that's 100. So actually, to be clear in this, let's just replace length with n. So now we have a length of 100, right? We're picking 100 variables. It's from 1 to 10,886. We're not replacing, and equal probability weights for each number. So we're just going to save this as random, which will be a variable. So we run this. If we wanted, we could view random, which is just a bunch of random integers within the range specified, and it's of length 100. So now we are going to assign, just put these random numbers in into, we're going to assign these numbers to the sample.m, right, to the sample.m vector. So basically, right, we have sample.m nothing comma 1. So this refers to you're going across the rows, or for all rows, and then column 1, and we want everything in column 1 to be train.atemp. So this stores train.atemp, and then in brackets random. So random is, of course, sorry, we'll view that again. So random is all these lists. So basically, it assigns wherever it assigns train $atemp at all of these row positions to the sample.m matrix, and then the same for count. So if we do this, right, and then we view sample.m, now it has assigned the atemp for all of these row locations, and then the count for all of the row locations. So now we have basically a random pair, we have a random sample of data points from the trained data set. So just to show that this works, remember that the first entry is 2,891, right? And then these are the two, the atemp count pair at that location. So let's just look at sorry, nope. So train, no, sorry, train.atemp bracket 2,891, right? So we see that's 32.525 as expected. And then likewise, if we reference count at that location, we get 182, which is as desired, and you can see here. So then now that we have that, we're just going to run a test regression 2, and we're just doing, sample.m, column 2, which is count, and independent variable is atemp sample.m 1. So we will do that, right? And then so now like summary, we get another regression. You see that the p-value is a lot higher, which is expected when you have a much smaller data set, even if a trend exists with such a low r-squared value, multiple r-squared value. You're not going to get as low of a p-value with a smaller set like that. So that is how you do a sample that's just a nice way to do like a little sample regression, if you'd like to do that. So next we're gonna do a regression on a categorical variable. So a quick note on the sampling one. This is like just one way to do it, but if you were then going to use it on another data set and do predictions, you'd want to see how we labeled atemp and count. You'd actually want to do count tilde atemp and then data equals sample.m. So this is just like a test to like look at what happens to the regression, but if you're then going to predict it, you just would want to keep everything consistent throughout so that your test regression can reference another data set and then use it to predict. So we're actually going to do that eventually, not with the sample regression though. So yes, moving on, sometimes you might do kind of a categorical regression and see what happens. So let's just view train date time. Right, so you see this like this crazy format. So I'm not going to go over this command, but because it's just very technical and something you can just reference. But basically, we're specifying, we're using strip time to kind of extract data out of this somewhat funky format. So we're just basically stripping it. This specifies the format's in now, and then this last entry is like what we want to extract. So literally, we're just extracting only the hour out of this, and then saving it as hour. Again, it's more about just referencing it because it's a pretty complex command. So right, we're saving that, and then we're going to do hour.f and save it as a factor variable because, right, again, it's a factor variable, not a continuous variable. So use the as factor and then what you're saving, and we're just going to save it as hour.f. So, right, we do that, and then we're going to view that, and you see now it just, the range is 0 through 24. We see that's 0 hour, first hour, 1 a.m. to blah, 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 and then it's, I guess, military time, so you get 20s, 19s, 17s. And then we do a test regression between count and hour.f plus temp. So we're doing hour and temperature, and then data equals train. Note that while data equals train, hour.f is specified elsewhere, so since you cannot find hour.f is an outside thing here. Data equals train, though, for count and temp. And then, right, so you then get a categorical regression, which of course since you have to do separate regressions for each factor, right, you see that you have the intercept and then the estimated value at each thing, or like how significantly it affects it, and of course at the end you get temp. You have your p-values. At the lower hours, you have pretty high p-values. Relatively speaking, that's probably just because you probably just don't have very many data points for that. And then the p-value gets much more significant once you get to the higher hours. And of course, you all see that temp has a p-value of that. And now that we're using the factor variable, in combination with temp, the multiple R squared goes up. So that's indicative that that hour itself has a pretty profound effect on predicting it. So that's from the summary. So now we're going to load in a test file, which is basically just a set of hour, date, time, like train, but it doesn't have a count, so we're just basically predicting count. So we're going to just read that. We know how to read a file. We're doing the same thing with the hour format again, where we just extract the hour, save it now as hour.f. So we're now we're overwriting the hour with hour from the test one versus this is train. So we're just overwriting this variable, overriding it, and then we're overriding hour.f again. And then now to test it, we're going to save a test2 file. So the problem with, we're going to use the predict function to test, to make our test. The only problem with this is that there's no, right, there's no, you see here, right, these are all variables, but of course we have the intercept, and the intercept, it's a, quote, variable where the, instead of having this, you'll just have constant ones throughout. So we actually have to add a column for the intercept, right? So you see the intercept here, basically just negative 71.92-ish multiplied by 1 for every single row. So that's a little bit of a weird thing about R, which should be fixed. But so to do that, we're saving a test2 instead of test1, and we're using the cbind function, right? And we're cbinding all ones, then hour.f, right, which we're using, and then the test data file, right? So test is just it's the CSV file that we're testing. We're binding hour.f, which is right, we extracted and now is a variable that we've overwritten, and then all ones, which just refer to the intercept, so we multiply the intercept by 1 every time. So we just use the rep function, and then we just do the first entry is 1 because that's what we're repeating, and then the length of that is just test $temp, so it's repeating ones of length however long the test file is. So you see it's 6,493 observations. So length test $temp as expected, we'll just prove here, is that same length. So that's the length. So now we're going to save the test file, and just because it's nice, we're going to do view test2. And then, right, so we just have this will correspond to being the coefficients for the intercept term. We have hour.f saved, and then we just have everything else. And then, again, it's just going, the predict function will literally just extract, we'll just extract temp and see it and then use that as desired. So right, we use the predict function, and in predict you literally just do predict. You see wherever the regression is saved, and right, we ran the regression beforehand on the train set, and then the next thing is what is the file that you're predicting off of, right? And so we just created that as test2. I'm just going to save it as S. So predict test reg 3, comma test2, and then of course the count is not going to. Of course, a regression is not perfect. We see that we have a 0.59 R squared value, so sometimes you might get negative values, but we know that you can't get a negative count. So we're literally just going to replace all negatives with zeros, because that will just make the prediction closer to reality, because obviously you're never going to get a negative. So we're assigning S and then at a certain location with a 0. So which basically is where this occurs. So S and then location where S is less than 0, you'll just replace with a 0. Because if we were to view S now, well, this works too, right? So you see negatives, a lot of negatives, so we're just going to replace all those negatives with 0. So right, and then we view S, and then you see these zeros. That's because beforehand the prediction was negative, and it's to your benefit to just replace that, because you never again will get a negative. So right, these are just the predictions, and then of course, you know, if this is a class project or something, when you're doing predictions, probably, you know, you'll have then the answers to the predictions, and then you can I won't show you how to do it, but you can just, you know, kind of calculate how accurate your predictions were based off, you know, by comparing the predictions to the actual values. So yeah, I hope you. Oh, and lastly, let's just write our predictions. Right, that will just go to your working directory. That way you can submit this if it was like a project, you know, predictions, or you can share it with someone. But yes, I hope you now have a better sense of R, and you know how to, you know, do basic things, really, from understanding the general concepts of the language to running regressions, predicting them, manipulating data files, and what have you.